So, good morning and afternoon, everyone. Welcome to our webinar on investing in nesting using Fusion 360. This is our overview to show you how you can increase efficiency and reduce cost. I'm Wayne Griffenberg. I'm a tech specialist on the Fusion 360 team at Autodesk. Today, we have our product manager for nesting and fabrication. Ravi Javia is with us today to go through and help show you guys how you can optimize this workflow. So a quick overview on myself. I'm Wayne, as I'd mentioned. I have over 20 years experience in the design of medical products. So I did get my MAT at Penn State University way back in the day and spent some time in the industry developing some infant incubators and warmers over 10 years in Pennsylvania, and as well as a new project or a new product design for implant knees and hips. And I spent a good majority of the time interwoven in my career working with customers like yourself and people and innovators like yourself, bringing this technology into your manufacturing processes. So also we have Ravi with us. So Ravi, let's hear a little bit of background about yourself.
Hi, everyone. I'm Ravi Javia. I'm the product manager for all things nesting and fabrication at Autodesk. And as part of my education, I have a background, a bachelor's in mechanical engineering, as well as a master's in engineering management and systems engineering, both from Stevens Institute of Tech. And I've been in the nesting and fabrication domain for the last 9+ years, working mostly at Autodesk on the TrueNest standalone product, which is our more advanced nesting solution. And then more recently also on Inventor Nesting, which is our nesting solution for product design manufacturing collection, and the new nesting and fabrication extension for Fusion 360, as well as the Arrange tool, which is also for Fusion.
Awesome. Thanks, Robbie. Very knowledgeable guy to have on the team. He's a pleasure to work with, and we're fortunate to have him here with us at Autodesk. So we're going to get into today, and we're going to cover ways that you can win more business, how to improve efficiency, and minimize waste within your product. So reasons why you would consider thinking about nesting for your business. We're going to provide some background on some designs and materials and some tips and tricks on workflow when you introduce this into how it's introduced in our industry. We'll also talk about some application best practices and tips along that line as well for nesting and fabrication. So we're also going to jump into the product. I'm going to walk you through step by step a way that a customer implemented nesting for their business. And as we summarize, we're going to talk a little bit more about how you can optimize or enable the extension to help you optimize your business. And at the end, we're going to provide some more information how you can reach us and reach out to our team to ask questions to get more info on the interface. So before we dive in, I'd like to give you a little bit of background on Autodesk. So Autodesk is a software company. Our mission is really to enable innovators such as yourself to be able to design and manufacture better products. We're going to help you we want to help transform the way you make those products and help you experience your ideas before they become reality. So Autodesk is focused on multiple sectors of our business, 3 sectors, one of them being media and entertainment, where we provide professional tools for rendering and animation like 3ds Max and Maya. These are used to make major motion pictures like the Avengers series or Spider-Man, and even award-winning video games like Halo or Detroit Become Human, which is a game that my kids and I can't stop playing. So we also have tools in architectural and engineering, another sector we focus on, where we connect large building projects with construction projects using tools like AutoCAD and Revit. And it's all within a collaborative environment called BIM 360. We also have a major focus here at Autodesk on design and manufacturing, where we have a collection of applications for product design. That's our CAD side, for simulation and analysis on our CAE side, and manufacturing like integrated CAM and integrated tools within Fusion 360. So that's what we're here today, is to talk about Fusion 360 being that one platform where all of that capability is combined and you can access that within your business. So one focus today is on nesting and fabrication extension, as well as how to improve your business, become much more efficient, and remove waste in your process. So Ravi, please take the helm.
All right. So first of all, what is nesting? It is the process of laying out cutting patterns to maximize your material yield and minimize the waste. Right? But what's more important is, why do we need nesting and why is it important? Automatic nesting can generate layouts for parts grouped based on like materials and thicknesses. And the nests are optimized then across various sheet sizes and prices. So it does all of this while constantly trying to optimize the results for cost, which dramatically speeds up not only the planning process, but also the manufacturing process, so that you can make timely deliveries for your orders. And a significant portion of the overall manufacturing cost typically comes from two major factors, right, which is material and time. With the use of an efficient nesting and fabrication solution, you can minimize not only the material waste, but also program your machines faster. And as a result, you can take on more work, bid competitively on contracts, retain larger profit margins, while reducing the unit production costs. So let's take a look at some common materials that are typically processed using a nesting solution, right? You have your regular sheet metal, heavy plates, wood, whether it's MDF, laminate boards, hardwood, etc. Anything ranging from concrete panels, foam, grading materials, even as much as including bars, extrusions, rods, and similar linear stock material, right? So what we're looking at here are a range of planar materials where the cutting is generally happening along the X and the Y axes, and there's some control, depending on the machine that's being used, there's some depth control to figure out the Z motion. So then you might ask, what are the real world applications for this, right? Where is it used? The three main areas of focus for our nesting and fabrication solution within Fusion 360 are sheet metal and woodworking, which comprises of both, whether it's furniture design, cabinetry, etc. And then the other areas, as you see listed under, plastics, composites, manufacturing industry, fabric, etc., are not a part of our initial focus as we launched the nesting extension. Here's some examples of common finished parts where a nesting solution was used during the manufacturing process. Includes things ranging from artwork and signage, custom truck bodies, electronics enclosures, barbecue trailers, snow plows, metal cabinets, and flat pack furniture, etc. Right? There's a lot more. These are just some of the examples. So you get the point. How nesting is used, where is it used, what are the common use cases? Now, a very important piece of the overall workflow when it comes to designing and manufacturing, and where nesting is involved, is to figure out how to cut the nested part shapes, right? And what CNC equipment to use. So normally the type and the thickness of material being processed and the industry application of the finished parts are particularly important when determining what CNC machine is best suited for the job. So let's talk about some of the nesting and fabrication methods, right? And as I mentioned before, machine is an important piece of the puzzle here. The type of machine and the cutting process involved often dictates how the parts need to be nested. The most popular and the commonly used method of nesting is the true shape nesting algorithm, where it optimizes the part placement for the random part shape geometry and sizes to maximize the material usage. Some of the common machine types that are used for such cutting are profile or torch-based cutting machines, such as lasers, plasmas, water jets, etc. But then also applicable are routers and punch presses, which utilize true shape nesting as well. The next most popular method for nesting, of nesting, is rectangular nesting. This is typically used to drive saw cutting equipment, whether it's your linear saws or panelizer machines doing the wood panel processing, etc., or even shearing machines that are processing sheets out of a material coil feeder, for example. And the main reason for this requirement of rectangular nesting is that once the saw blade plunges into the material, it can only move in a linear direction. Therefore, the way in which the parts are laid out must respect that, and it's an important restriction for nesting. Next on the list, we have linear nesting. This is applicable for processing linear material stocks such as bars, rods, extrusions, etc. And the typical machines here are chop saws or miter saws. The output of the nested results can either be a cut list or in the form of NC code to drive your cutting equipment. And then last but not the least, we have our high volume packing logic, which essentially optimizes the repeating die pattern. A common example or a use case for this would be for stamping machines, which is, again, often processing material coming off of a coil feeder. So while all of these nesting algorithms are supported using our nesting technology within Autodesk, the more advanced standalone product, TrueNest, supports all of these different algorithms. However, only the most popular one, the true shape nesting algorithm, is supported within Inventor nesting, as well as the new nesting and fabrication extension for Fusion 360. So with that, let's talk about the benefits and capabilities, right? Design and manufacturing is often an iterative process where the two really need to be tightly coupled together to prevent slowdowns in the overall workflow and to avoid loss of information during the translation and the syncing process. And one of the biggest benefits of having a nesting solution directly embedded or integrated with your CAD/CAM software is the associativity that comes with it, right? This enables you to modify your designs and quickly regenerate the nest results to consume all the design changes without requiring additional rework. What does that mean? This means a change made anywhere appears everywhere. And with Fusion 360's library of post-processors, you can also generate toolpaths and NC code to drive your CNC machines. So it completes the end-to-end workflow. It allows you to go from design to nest to NC output to drive your CNC equipment. Now, there are additional benefits, of course. It includes the ability to compare and contrast different nest studies with varying settings, and Wayne is going to walk us through some examples shortly here. But it allows you to compare and contrast these studies, which you can then use to determine the most optimal results for quoting, manufacturing, as well as reporting. Not only that, Fusion 360 provides you the platform for collaboration, so multiple users within the company can be working off of shared settings and presets where the workflow is standardized, not just for one user, but everybody at the company. So with that, I want to leave enough time for Wayne to go over the demo. So I'll switch it over to Wayne to show you a live product demo.
Awesome. Thank you, Ravi. And it's pretty amazing that a lot of those TrueNest tools can run natively inside of Fusion 360, and you can optimize your workflow and might have a much more efficient flow through your fabrication process. So part of that is a story I'd like to tell about a customer we worked with not so long ago who was designing tool chests and CNC tool carts like the ones you see on the screen. Not exactly those. These are ones we made representative to help teach and train and implement that process. I'd like to walk you through some of those steps directly in the product. So much like this customer was working with their plasma cutters and they had a small shop, they started to grow quickly. They got orders in, especially for their tool carts, which were very popular. So they ordered a water jet that they used in their shop. The OMAX, very similar to the one we have at our Pier 9 facility in San Francisco at Autodesk, the OMAX 60120, which gives them a 10 or 5 by 10 sheet capability. And setting up our workflow for nesting, I'd like to walk you through those steps that they would use to set up their OMAX as well. So, and they also started from a point of view where they're using AutoCAD to do a lot of DXF output and DWG drawings, which they were programming directly into the control of the machine. Now, one aspect of making that design, especially within Fusion 360, is you have one single source of truth. You design it in 3D to represent the actual physical product that you're going to make in the end. Along with that, you have the capability of designing in your different part family as well. So in this case, in one design, again, one single source of truth, we're able to design both the tool chest as well as the tool cart that you could switch easily between the two, saving a lot of time, especially not drawing all the 2D flat components where in our sheet metal capability, you can flatten out a component really easily, design it for 3D usage, jump into sheet metal, make a flat pattern of your different components, and you could simply flatten them out to be able to use for the fabrication process or make drawings and so forth. You can even export from here a DXF of that design. So to make that process a lot more smooth and streamlined, we now have added the capability where you can nest the components for fabrication directly within Fusion 360. So as Ravi had mentioned, we now have that capability through the TrueNest integration now running natively inside of Fusion, where you can enable this through our nesting and fabrication extension. So towards the end of our meeting today, we're going to give you a little bit more insight on how you can enable this functionality. I just want to show you, you could just enable it in the product. And once you enable that, you'll now have a tool built into your design workflow that you can set up for nesting. So I want to prepare this job for making these tool carts. We want to make a few of them for our customers. We could select the different components that we want to nest to make sure we have the flat panels all aligned, as well as components that'll be nestable. So I don't want to bring these casters in. And in this case, if we look at the tool cup, this is a plastic purchase part that we bring in to make those different tool cart or tool holders. We don't really want to nest those, so we can ignore them in this job. So we're only going to output those nestable components that we can make on that water jet. So now we just defined those different components. I'm going to switch over to manufacture. So now we can apply that directly for nesting. So I'm going to jump into fabrication, into which we now have the nest tool. And inside of nesting, we're going to create a brand new nest study for this tool cart. And of course, we can create one for the overall tool chest as well. But in this case, our customer only wants a few of these tool carts. So in our workflow, going from left to right, a workflow you're used to within Fusion 360, we just simply create a new study. I'm just going to put in here, new study. And you can name this what makes sense for that study. In this case, we're going to try to make 4 of these. So I'm going to go into use 4, well, not 14, 4. So we're going to make up enough to make 4 tool carts. Our shapes we can define and just check and hover over to make sure that we have the right components that we want to nest. So if I see any of those tool cups in here, I know that I don't want to nest something that's not nestable in my process, right? And as long as we have the flat panels of those sheet metal components, we're going to be good to be able to nest them together. We're going to talk a little bit more about packaging, but you can list all of the different stock shapes and sizes and thicknesses of the material that you want to use for nesting process. And you can apply them here in packaging. Set up our parameters. And one thing I like is being able to minimize and reduce any of the waste where we can have our components specifically that would have remnants on a shape that we can now cut off on our stock. So I'm going to leave this at length or width and length. And I also want to make sure that we are going to create our manufacturing model that we create stock as well. So we can use this and automatically set up the stock we would need to run on our water jet. So I'm going to say OK, and Fusion nesting now nested those components. So now we have multiple nests that we can view in our study, and we can see the different ways that it places those components in the most optimal way. We minimize a lot of that motion of our tool, right? So we don't have overuse of the tool as well. And it also minimizes that waste in these different sheets. So I'm thinking that was pretty quick. I remember working, especially in the incubator, where we'd have the flat incubator hoods, how long it would take to do that manually, to draw up the components, to lay them out and space them correctly. It took hours. We just did it in seconds. So it's amazing to be able to take a design like that and nest it out, to be able to make 4 of those different products really quickly and easily. Right. So, and one of the major things was, imagine we have a change to the product, right? So if I go back into the design and the customer actually wants the version of this that's not 4 foot long, we can use parametric design to drive the changes and design our product. So let's say we go from our 42 to our 52 or 48 to 52 inch version of our tool chest, or in this case, our tool cart. So it's going to expand our design. All the components that are associated with this design are updating as well. So it stretched all those components, all those pieces, and now we have it placed exactly the way the customer wants our design. So all we have to do is just update all of our flat patterns, and it updates in the background all the sheet metal flats, so that now when we go to update our nested components, it's going to use the latest flat version. So if I jump back into manufacture, and we just simply have to update our nested components, and you'll see it'll update on our sheets. So any design changes you can push from one source of truth directly into your design. So we're going to regenerate that nest. Now it's going to realign those components according to the new size and shape. So if you added holes or added or removed different features, you'll see it updates your nested components according to those new shapes and sizes. So even that, having a design change, being able to push that design change right through the nesting workflow all the way through, and eventually you're going to see we're going to add some CAM toolpaths, and now we can maximize that workflow. We can see exactly what we're cutting on the machine matches the design and matches what our customer wants. So that's a huge innovation and a time saver as it is being able to do that and make that design change. So another aspect, I did reach back out to the team who was designing the carts as well as the tool chest, and they did add a new capability into their shop. They did bring another water jet. They actually had an opportunity, and the business was going really well. They did bring a larger water jet into their process. Now they can do a much larger sheet. They were working with 6 by 12 sheets in their machine. And one of the questions that came up is, what does that look like? Can we do some analysis to find out if we get a better flow or better throughput from one machine to another? Can we use less stock, less material, and have less waste if we use a larger machine? Now, again, looking into the cost of the sheet, looking at material cost and overall efficiency throughout the process, it's absolutely something we can look into. So it's just simply creating a new nesting study for the new workflow. So if I go into a new nest study, we're going to say this one will be study 2. I'm just going to call it study 2. And you can name this again, anything that you'd like. We're going to cut 4 sheets, but in our packaging now, we're going to choose the larger sheet. Now, I'm going to choose the top one there, our 72, but let's say we wanted to try it with our 60 by 120. Right, so I'm going to delete this because we're already using that larger sheet. So I'm going to delete this one here, and I want to do a comparison just to find out what would be the more optimized workflow using one sheet over another, where we can optimize a different machine, one machine over the other. So now we have a nested study of the smaller sheet versus the larger sheet. So we can see using the larger machine, we have a throughput of 4 sheets, 6 sheets on the smaller machine, right? So now we can define what that workflow would look like, and we can even do a comparison between the two. So if I take our nest study, in this case 17, with our nest study 18, in my case here, and I want to compare those two, I just simply go and compare, and I can see what the differences would be between those different nest studies. Oops, I think I only did one there. Hang on a second, let me grab them both. I'm going to hold Control, and now we're going to do a comparison between those two studies. So we can see side by side what our efficiency would be, our actual remnant usage, right, and our overall total cost difference between the two of them. They're pretty close in this case because I think our sheet size is relatively close when it comes to optimizing or looking at the cost per sheet. But there are some cases, and I remember talking to Ravi about this, where certain cases where we have special cut sheets or special size sheets for a machine where we want to get 2 sheets onto a bigger, larger machine, that could actually cost a lot more for special size and special shapes to be cut specifically for that workflow. And we can do a study on those different sizes to find out where our most efficient result would be within our workflow. So we can even compare what the remnant cost would be and our overall efficiency nesting efficiency between each different workflow. So it looks like from a cost savings point of view, it might be better to use the smaller sheet with multiple setups, multiple sheets, versus the overall total nested cost of the larger machine, which now we can free up for other jobs. We can even add other components to be able to use and yield that machine. So it looks like Nest 18, just looking at the comparison, might be the one we want to set up to cut. So from there, we can absolutely choose our Nest 18. I would like to set these up to be able to cut on the Omax water jet. Just right click and we can create setups for all of those different machine models, right? So they're already nested. We already have our stock size. We have them placed, the different components, and now we just created multiple setups for each of those different sheets. So in the first setup, if we decide we want to cut these components out, I just simply jump in and do inside of that setup. We could choose to do our fabrication. I just want to check and make sure that that setup is set for cutting in this case, because we're going to cut it using our water jet. And that's okay. It's just giving us a warning saying we might want to select some additional parts, and that's okay. I'm going to select it within the toolpath. So in this case, I want to be able to cut that. So I just choose cutting. This is our workflow for CAM, going from left to right. A simple workflow selecting the tool for the job. So inside of here, if I go to our Omax water jet, you could easily set up a tool library for those different tools. So select the tool for the water jet. The geometry we want to cut, I'm going to select right off the part. And if we have a sheet, I could just simply select the same plane faces and it grabs all those different geometry for this job. So you just simply define it off of that first part. If you want, you can add some tabs in there to hold onto the part while you cut the inner loops and keep the outer loop part. You can decide if you want to use tabs, our heights, which are color coordinated that show exactly what our clearance is above the part. Our passes, how much that tool is engaged throughout the cut, including our compensation of the beam. And in some machines, we have that in the center where compensation happens at the control. So you do have some options on the way you approach. And then our linking parameters, how we're piercing in the material, leading in and leading out. So now we have set up our CAM workflow. We could simulate what that's going to look like before we go and send it the toolpath to the machine. We can see it's cutting all the way through. So now we can simulate that sheet. The end result is to get the code out for our OMAX. Just simply go to post-process. Now, in this case, I'm going to add an NC workflow into here, or we could just simply select the one that we want. In this case, if I do multiple sheets, I can just simply grab that toolpath, post-process. We can output using our cutting workflow for the OMAX water jet. You can see we have a lot of posts that come with the software for cutting in those different types of machines, water jet, laser, plasma. In this case, I'll grab the OMAX. Oops, let me grab the OMAX there. And we're going to output specifically to be able to run this nested sheet in the OMAX water jet. So now we get the resulting code that we could send right over to our OMAX to be able to cut out those components. So that was it. That's the workflow going from that design, using that tool, that integrated tool for preparing for nesting. Once we prepare it, we have all those flat panels for those sheet metal components. We jump into manufacture. We walk through a nest study, simply going from left to right, selecting the components, talk about our packaging, being able to have our output, and it output the nest studies. In this case, we actually have 2 different nest studies that we want to compare different size sheets. We did some reports in the comparison. And now if I output this code and I want to have a report for our team, or maybe even a report for the customer, we can now output a report that'll give us an overview of what that nest study looks like. So from this report, we could see efficiency of our parts that we're making today, our inventory, what we have in stock, our cost analysis for that inventory, each sheet that's set up within our nested workflow, and it's giving us that input on each part that we're making and the efficiency that we're using in this process. And at the end, we have an overall report that we can save, send to our team, send to our customer to show what that efficiency looks like, as well as part summary. So this report will help us at least take a look at where the best efficiency would be, what it looks like as far as cost analysis within the sheet, where our waste would be in the process, and it helps us surmise to a more efficient workflow. So we can think about the next setup we do of the next project, and now we can compare it and take a look at what we've learned and increase efficiency in our whole overall process and save money. Now, this report can be saved out as an HTML or a PDF that you could save with the job. And again, bring back with the team to show exactly how your efficiency is improved. And now we have our setups. We can just simply go into our setups, output our code, and now we have that whole streamlined workflow. Much, much better than doing a lot of this nesting by hand. A lot of automation tools built in, and you can absolutely optimize your workflow for efficiency. So with that, I'd like to get back in and take a look and just kind of summarize where we're at. And I know, Ravi, we did talk about those different benefits as you were giving us an overview of how that efficiency and optimized and minimizing waste. And so I'd like to just to at least summarize what those benefits look like after that process. Yep, so we're able to maximize our material yield, predicting material usage, use some of those reports, use the capability of the comparison and looking at where the best usage would be according to the size and sheet and machining process that you're going to use. You can estimate how much it's going to cost per part, your part production cost, bring that back into your design workflow, and now you can make much more efficient changes to your process. And once you change it, now that change will be pushed throughout your single source of truth through your manufacturing process. You could CNC run your programming and just simply update it, and you can run your CNC machines a lot quicker. So the end result would be saving time and money using nesting and our fabrication extension.
Not only is it optimizing just for efficiency alone, but it's also taken into account the overall cost of manufacturing, making sure you're able to manufacture the same parts cheaper, right? So let's take a look at how you can access the product. As Wayne was showing earlier, from the top right-hand corner of your Fusion screen, there is the Extension Manager dialog, and under there, if you click on the blue button for the access options, there's different ways to access the product. You also have access to a 7-day trial, just like the other extensions for Fusion 360, and a little bit information on the pricing. So, like I said before, there's different ways you can access the extension. You can purchase an annual extension subscription from either the channel partners or the resellers for $1,600 a year. You can purchase the same extension directly from the e-store or from our direct Autodesk sales hubs, which are in the Americas. There's a sales hub dedicated for Europe, Middle East, and Africa, and then there is a dedicated sales hub for Asia Pacific. The digital sales via the e-store or the hub also have an additional offering for a monthly access at $200. And then last but not the least, you have a cloud credit or a tokenized consumption model, which you can get daily access to the extension at 25 cloud credits per day. So with that, back to you, Wayne.
We were able to show you how you can win more business or improve efficiency or minimize waste in your process. And these are reasons to consider nesting for your business. We provided some background on designs, material, workflow tips in our industry that you can apply to your business again. And so we also discussed our best practices within application of nesting and fabrication, and walking through ways that you can now apply it directly to your design, select those components that you want to nest, jumping to the nesting workflow that we showed you here. We'll go through an example of what that tool chest and tool cart implementing in their business, going from a more manual process to automating the nesting process to help their workflow and eliminate some of that waste. We did show you how to access. Thank you, Ravi, was able to give you more information and insight on how you can access, and especially reaching out to our team. So please feel free, reach out, contact our team all across the globe. You can access our sales team, reach out, ask questions. If you want to get the extension started, we have teams specifically to answer your questions. So any additional questions you guys have, if you're watching this on YouTube, please ask the questions here. We check the YouTube site, and if it's not myself and Ravi, we do have experts who can answer those questions for you. So thanks for joining our webinar today. Stay tuned. We have a lot more in the near future when it comes to our extensions and Fusion 360. So thanks for joining us. Have a great day.